Hello, everybody. Good morning, good afternoon, good evening. Thanks for attending. My name is Laurent Polidori. I'm the president of ISPRS Technical Commission 3 Remote Sensing. And on behalf of ISPRS, the International Society for Photogrammetry and Remote Sensing, it's my great pleasure to open this webinar dedicated to some remote sensing applications. I just would want to recall that Technical Commission 3, so dedicated to remote sensing, is organized into 12 working groups for the period from 2022 to 2026. The main activities of these working groups has been to contribute to the midterm symposium of the Commission that we organized in November and that I had the pleasure to welcome in Belém in Brazil, my home city. But beyond this particular event, each working group has its own activity, its own calendar. Working group 9, dedicated to human health applications of remote sensing, under the leadership of Dr. Murali Krishna Iyyanki, you have organized several webinars in 2024 with the support of the ISPRS Student Consortium. So thanks, Lashmi, for your valuable help for organization and communication. So congratulations for that. And I'm very happy that this webinar series is going on in 2025. So I take this opportunity to wish everybody a very, very successful new year. So this webinar will be today with Dr. Patricia Mwangi, who is the new chair of Working Group 4 on Land Use Land Cover, and Dr. Niti Anandan. So please, Dr. Murali Krishna, I think it's time for you to present the speakers and introduce this new webinar. Thank you.
Thank you, Dr. Laurent, the president of the ISPRS Commission 3 on remote sensing. As a chairperson of the working group 3/9, I have great pleasure in introducing two speakers for the day, and I will start with the first speaker, who will be the Dr. Patricia Mwangi, who will be speaking on the spatio-temporal analysis of nitrogen dioxide and LST Nairobi City County. Dr. Patricia is a geospatial engineer with over almost 10 years working experience. She graduated from Nairobi University with a bachelor's degree in geospatial engineering, and she proceeded to University of Florence at Italy and pursued masters in geomatics application, then natural resource evaluation. She completed her PhD from Kenyatta University, and the focus of her specific research was modeling the spatial relationship between built-up volume densities and surface heat islands. Today happens to be the day of discussion of surface heat islands, with both the speakers being experts in this particular subject. She currently lectures at Kenyatta University in the Department of Spatial and Environmental Planning. And Dr. Patricia's research interests related to urbanization, land use, land cover changes, and their climate. It's a great pleasure in inviting Dr. Patricia to speak for next 25 minutes on spatio-temporal analysis of nitrogen dioxide and LST in Nairobi City. Dr. Patricia, please.
Okay, thank you very much, Professor, as well as all the panelists. Thank you very much. As we've heard, my name is Dr. Patricia Mwangi. I'm a lecturer at Kenyatta University. So today I'll give a brief introduction and analysis on the spatio-temporal analysis of nitrogen dioxide and land surface temperature within Nairobi City County. So I'll give a brief introduction. This is the content of my presentation. I'll give a brief introduction on air quality, and then I'll talk about the air quality measuring satellites, some of them. And then we look at a study area whose focus is the Nairobi City County, and then a few results, as well as a brief conclusion and summary of the findings of our area. So in our environment, there are various sources of pollution, and some of them can be natural sources, others can be mobile sources, such as our vehicles, sometimes air conditioners. In our urban environment, sometimes what we burn, and these are some stationary sources, industries, and so forth. Our human activities, we're always emitting different types of different sources of different types of gas, and their interactions tend to produce also different types of pollutants. So we have those that are classified as primary. This is important because air quality and urbanization, that in terms of 2D and 3D hazards. So I will talk about one of the satellites, one of which whose data source was used in the analysis. So this is Sentinel-5P. So this satellite particularly has 8 bands and has an 8-band spectrometer instrument, which is able to take different forms of, so mainly what it does, it measures mainly within the troposphere. And this one, what it mostly uses, it uses the ultraviolet, visible, near, short wavelength, infrared light spectrum. So that is the range in which it measures different reflectances within our atmosphere. And why this is critical is because it's able to measure trace gases and aerosols, which are relevant for air quality and climate. In particular, for this study, I used nitrogen dioxide concentrations to understand its dispersion in different gases or aerosols that the satellite is able to measure. One of them is nitrogen dioxide, which was used in this study. The other is looking at the ozone, which is critical. And then we also have methane, carbon monoxide, as well as sulfur dioxide. So another one, which is mostly used and also used in air quality studies, is our satellite by NASA. So one of the things that it's able to measure is the ozone layer. When it comes to air quality, we have, and why this is critical is when it comes to the aspects of climate change. Others that are used when it comes to looking at methane, they vary, and some of them are still in use. And others continue being able to measure for a few decades to come. Understand the study area. The study area, the full city of Kenya, it has a square coverage of about, and we within it. So a description of the different types of data sets that were used. The data sets were analyzed from the year 2019 to 2023. This was done in Google Earth Engine, where average values for the whole of 2019 were taken 2020, 2021, 2022, and 2023. So these are some of the data sets that were used. And as you can see, the concentration of nitrogen dioxide concentration, the values are mainly within the center area of Nairobi. This is mainly the CBD, just to give you a brief understanding of the layout of Nairobi. Then towards the periphery, towards your right, these areas are not that densely populated. When it comes to building concentration, as you'll see, data sets were analyzed from 2019 yearly, from 2019 to 2023. The same other data sets for the same time period is land surface temperature. This is from Landsat 8. And the same averages were taken per year from 2019 to 2023 to understand the spatial changes and whether there have been changes in each one of these years. The other data set was population. And why this is critical is to understand which areas tend to have, for example, populations who are more vulnerable, especially when we're referring to health. So the areas that tends to have a higher population density is an area called Mathare, and I'll be able to explain later why this is so. But Mathare is one of the areas where we have one of the largest slums, I would say in Africa as well. So that's why the population density is very high. So we'll also be able to see the level of vulnerability in these areas. The other data set that I was able to obtain was on building footprints. This is free. And this I obtained from OpenStreetMap. This is not in 3D, but this is particularly in 2D. So when it comes to the results, I was able to obtain open source data. This is on rainfall from the year 2019 to 2023 and wanted to understand what is the trend and between the nitrogen dioxide rainfall. And what particularly stood out, content does have an impact on carbon dioxide concentration tend to be affected by reduction, especially in the rainy season. Concentrations were higher. Understand the trend, a way to understand what's the spatial distribution across smaller administrative units. And these ones, we refer to them as constituencies. So we have Nairobi and we have our constituencies, they're about 13. About 12, sorry. So within each one of these 12, it's important to understand what is the difference and the characteristics for each one of them. And I used for 2019 and 2023, a contrast of those between 4 years, between 2019 and 2023. And it was noted that in areas, especially where you have high, probably like areas with places like Kibra and Mathara, these are the largest informal settlements. So areas with low land surface temperature values are areas that have high urban forests. And these are areas, for those who are familiar with Kenya, this is a place like Westlands. So this area particularly has high concentration of urban forests. Then areas that have low vegetation coverage tends to have higher LST and nitrogen dioxide concentration values as well. So another result was to try see what is the relationship between nitrogen dioxide and vegetation cover. Same findings when it comes to what we obtained from LST, that there was a negative correlation between NDVI and nitrogen dioxide. And so this tended to indicate that population does have an impact on the values that you find in NDVI as well as LST and nitrogen dioxide values. So another analysis was on correlation analysis and wanted to find out, this is between population density, nitrogen dioxide, as well as the building densities. So it comes to the population density, there was a negative correlation between
Sorry. Sorry. Hi, Dr. Patricia. I'm sorry to interrupt you.
And this
I'm sorry to interrupt you.
An inference of showing and indicating that areas that tend to have higher populations would be an indicator that
Dr. Patricia, it looks like the internet was a bit slow at her end, and we might have lost her. Yeah, because she was informing us that internet is a bit slow at her end. We are sorry for this disruption. Maybe we can have her back. But in the meantime, maybe I can come up with the news. So I can see lots of members from student chapters are joining this, but at the same time, there are new people who are attending it as well. So I wanted to circulate this news that ISPRS SC has recently launched the concept of student chapter. Dr. Patricia, I just wanted to tell, is it okay if you turn off your video and also all of us, because sometimes it helps to lower the bandwidth, internet bandwidth, and then it will be helpful. So can we turn off our videos for now, including Dr. Patricia? Because the internet was a bit troublesome. So just to continue with the news, so we have recently launched the concept of student chapters. So any universities, if they want to form student chapters, you can have a look onto the application process that is available on our website. That whose link has been shared by Dr. Laurent previously. And if you have any questions, we are happy to help. So please have a look on the concept of student chapters, and if you want to form those. So Dr. Patricia, over to you. You can try to share your screen and continue continue your presentation.
Okay, I'm sorry for that. I think my internet is quite unstable.
Yeah.
Where did I drop off, kindly?
Yes, I think this slide.
Oh, okay, I'm sorry for that. So when I think, well, in this slide, mainly shows the relationship between moisture content and nitrogen dioxide concentration. And during the wet season, nitrogen dioxide concentrations tend to be lower compared to during the dry seasons. So here it also shows that climatic factors are quite important in understanding dispersal of pollutants within an area, especially in urban areas where many people actually live in. The other result was to understand the concentration or also the relationship of nitrogen dioxide and land surface temperature across different administrative units within Nairobi. Each administrative unit has its own population concentration and characteristic. Well, in Nairobi, we have about 15 informal settlements, and we have 2 in particular. That is Kibra and Mathare that are the largest, and Kibra, I believe, probably is about the second largest in Africa. So as can be seen from the results, areas that tend to have higher population, or rather these particular areas of the informal settlements, we tend to find that the concentration of nitrogen dioxide was equally higher. And probably the land surface temperature was not that high, but this is something that one can look at further because of aspects of what kind of building materials that are being used. That is using through albedo, but the study did not look at that. But there was an importance to understand what's the spatial differences in each administrative unit. The other was to try understand what is the relationship still spatial within each of one of these administrative units between NDVI and nitrogen dioxide. And the study just showed that areas that tend to have higher nitrogen dioxide concentration also tend to have lower NDVI values. So as seen in the previous slide, we have certain administrative units that have higher urban forests. So these urban forests, of course, do have an impact on the nitrogen concentration, dioxide concentration, as well as land surface temperature. So this is just an indication of this relationship, and also tries to propagate and also emphasize the importance of urban greening. So the other part of the study was to understand and get the correlation of between population density, nitrogen dioxide, and in the next slide, we'll see built up area densities. So with population density, there was a positive correlation with nitrogen dioxide as well as land surface temperature, which indicated that areas that tended to have higher population densities equally had higher values of nitrogen dioxide concentrations and land surface temperature. And in the previous slide, we've been able to see which particular areas tend to have higher concentrations of nitrogen dioxide as well as land surface temperature. When it comes to the nitrogen dioxide, with land surface temperature, there was a negative correlation, and it was quite interesting to understand, in particular during the lockdown period, what particularly happened. How are the nitrogen dioxide concentration? What happened to the land surface temperature? I've not been able to show it in these results, but in that period, the concentrations of nitrogen dioxide and LST went down. And I think this is globally, and this was the same trend that was found. However, in Nairobi, we did not have a complete total lockdown, but movement was rather restricted. One of the last analysis to just try and understand, is there an impact of how we build our cities in terms of density? Is there an impact? I did not look at 3D here particularly, it was just mainly in 2D. So in each administrative unit, the total area in terms of 2D of each building, the total area in each administrative unit was analyzed based on the density and the area of that particular administrative unit. A correlation was found with the population density, nitrogen dioxide, and land surface temperature. And the findings still collaborated with the previous findings about when it comes to build area density and population density. So within the first graph that is orange, the top one of building area density and population density, I had mentioned Mathara is one of the areas that have is an informal settlement that has a very high population. So in this particular area, the population tends to be quite high. Building density is low. The square area where people are living in is a bit smaller. However, it will be interesting to understand what's the 3D characteristic of this particular area. The other of building area density and nitrogen dioxide concentration, we've seen that it has a negative correlation. The negative correlation here would be indicative that in areas that have lower building area densities tend to have higher nitrogen dioxide concentrations. And also at the same time with LST, it indicates that areas that are still a negative correlation, it would indicate that areas whose building area densities are smaller tend to have a higher LST value. And there is a study that I had done previously to try and understand what is the relationship between the 2D aspect and LST and buildings, the smaller buildings or the larger areas. So these results do indicate that building areas or how we do build up urban areas does have an effect on the land surface temperature, as well as the concentration of nitrogen dioxide because of different forms of dispersal. So from the findings, it indicates that urban morphological variations across the city do have an influence in the interaction between land surface temperature, nitrogen dioxide, and NDVI. And also vegetation plays a very crucial role in air quality. So, and this is why, because it provides a form of shading and also in reducing air pollution by absorbing harmful gases. In conclusion, what I can state is that these studies are very critical to determine the quality of life. And why this is important is to evaluate environmental factors, and particularly in different administrative units. So you can get an overall value over an area, but once you're able to understand different areas in forms of the smaller administrative units, one can be able to form an informed policy, as well as understand which areas need greater focus and which greater areas, for example, would pose, or which people are actually exposed or have higher risks of certain diseases. So that is what I could say from the findings of this study. So thank you very much. Thank you for this opportunity.
Thank you, Dr. Patricia, for some brief and very focused presentation related to how starting from Landsat and Sentinel satellite data, and how we observe the LST changes and the parameters which are vulnerable for population. I think your research on how to relate the NDVI with the NOT pollution, nitrogen oxide pollution, with a specific reference on vegetation health, etc. If we can think about a day where NDVI can give a map of NDVI can give the extent of nitrogen oxide pollution levels, at least in a qualitative manner. I think your observations and your studies are very relevant, and I wish you all the best in further in your research in this important area of environmental pollution, environmental management. Thank you, Patricia, for your nice presentation. In spite of the fact that you had some local issue related to the internet, but that your focus on the topic has minimized any loss of information due to the internet presence. And I fully appreciate your commitment, your concern, and your dedication to study the environmental pollution problem in a developing world, in African country. Thank you very much.
Sorry, Dr. Murali, Krishna, are we taking the questions now or at the end of the session?
It's a very small thing. I think I'll take the permission of Laurent. There are one or two questions. Why not we complete them? Is it, Laurent? Is it okay? Yeah. Lakshmi, do you have any? Did you find any questions? I didn't see anything.
Yeah, it's in Q&A session, so I can see and read it if that is
please
okay.
read out.
So, Dr. Patricia, so the question says, how do you derive your built-up index? You mentioned NDVI derived from Landsat 8 data, but you did not mention normalized differential built-up index, NDVI.
Okay, thank you for that question. For the first part, how I obtained the built-up index, the buildings, obtained the area of each building, and after obtaining the area of each building, I then calculated the sum area of buildings within each administrative unit, and that is a constituency. Once I obtained that, I then divided that by the area of that constituency to get that density. So that was how I obtained the built-up index. So I talked about, then that's how I was able to find the correlation with different factors. Then the other is why I did not use NDVI is because I obtained the NDVI, and NDVI is like inversely proportional with the NDVI. So if I did the correlation, I had actually done some analysis with the NDVI and NDVI as well with the other variables. And I found that the relationship was more or less the same. And the focus at that point was mainly to understand what's the impact of vegetation within urban areas when it comes to land surface temperature and dispersal of pollutants. So my focus was, I decided to use the NDVI because the results were showing that areas with high vegetation tended to attenuate or reduce the land surface temperature, and areas with high with lower values of NDVI, the temperature values were higher. Same results are obtained when I used NDVI. So, but just opposite. So my focus then was on NDVI.
Thank you so much. So I think it is again another question by Mara itself. Maybe could be a follow-up question. So he's saying, why limiting your study to just 2 air quality indicators when Sentinel-5P provides 8 indicators?
The reason why I used nitrogen dioxide was because nitrogen dioxide, each pollutant is produced by a different source. And for nitrogen dioxide within our urban areas, that is one which is of great concern. And because of its interaction with other factors, then other gases can also be produced. So that is why I only focus on nitrogen dioxide. I didn't focus on sulfur dioxide because with NOx gases, that is a concern, especially in urban areas. So that is why I only used nitrogen dioxide. And LST is very critical because it affects your thermal comfort. So it affects how you feel. It affects indoor, how you are inside an area, and also outside when you're walking on the street. And especially it comes to urbanization and where we put in impervious surfaces, then it can affect, for example, actually aggravate different diseases, especially for those who are vulnerable. Those are the children and those who are elderly and others who may have different forms of diseases.
Thank you. So maybe one last question as we're running out of time, but feel free to put your questions in chat. Maybe Dr. Patricia can have a look on it later. And if we have time, we can take at the end of webinar. So the last question for now is, can you explain the data source and the data processing and data integration, particularly the spatial and temporal resolution of the different sources?
Okay. So for nitrogen dioxide, I was able to process it on Google Earth Engine for all years. And for LST, the same thing, Google Earth Engine processing for all years. And during what I am able to obtain is at 30 meters. So that is for the land surface temperature, Landsat 8, as well as what obtained from Sentinel. And then further analysis was done in ArcGIS. That is where you convert to different forms for ease of spatial relationship, overlaying it with different forms of data. So when it comes to the temporal resolution of the different sources, so as I said, when you're working in the Google Earth Engine, I was able to find the average for each particular year. So for 2019, it is data sets based on those that are available from 2019 January to December. And the single image that you're seeing, those are average values per year from 2019 to 2023. each at 30 meter. The same thing with land surface temperature. The same thing with NDVI from Landsat 8. And population density, we normally collect, have our sensors in 2019. So the 2023 population data, that was projected population data within in 2023.
Yeah. I think the Google Earth Engine is one of the very powerful cloud-based platform. I think particularly for satellite data processing, and it provides a lot of archives of satellite data and imagery from Landsat, Sentinel, and also I think MODIS also. Thank you, Dr. Patricia, for bringing out the fact how you use the Google Earth Engine, because it is offering a wide range of tools and features. So that becomes a good factor for some of the young students who are working, how can make use of the Google Earth Engine facilities. Thank you, Patricia, for a nice presentation. So I'll move to the second speaker. Can I, Dr. Laurent and Lakshmi?
Yeah, sure. We're running out of time. There is another question as well, but I think we can check at the end if we have time.
Yeah, please.
So let's,
yeah. So we are all waiting for Dr. Professor Nithyanandam, who is a professor of geospatial technology, and he's an expert in geospatial intelligence with extensive experience in remote sensing, GIS, etc. And he's also specialized in thermal remote sensing, one of the areas which also is being talked by Patricia. And his research initiatives in geospatial applications and public policy are also quite well known. Dr. Nithyanandam got his PhD from specializations with thermal remote sensing from the Hong Kong Polytechnic University. He established a bulletin in Takshila Geospatial Bulletin, and he is basically he's working on the analysis on geopolitical and environmental issues. And his vast expertise, a lot of projects he has executed. So for want of time, I'm minimizing. Briefly, let me say, he has been instrumental in advancing urban heat island research, focusing on quantifying the anthropogenic heat emissions and developing mitigation strategies for many vulnerable communities in urban environments. He is currently a professor and head of the Geospatial Research Program at Takshila Institution, Bangalore, India. So may I request Professor Nithyanandam to make his presentation on urban heat islands mapping for sustainable cities. Professor Nithyanandam.
Thank you. Thank you, Chair. Thank you, President. Thank you, Lakshmi. I believe I'm audible to all of you, right?
Yeah, you are very much.
Yeah, perfect. So, and also thanks to my co-presenter who has given an overview on LST and other topics. I'm not going to get into like how you calculate it, though I will show some of our results. My idea today is to share what is all about urban heat island mapping per se, and what are the do's and don'ts. That's more important because it's very easy to say you go and take a particular satellite and then process land surface temperature out of it. But there are certain things that people presumes and people makes mistake given the experience of working in different parts of the world on the topic, be it on a European part of the world or be it in a country like Hong Kong or in India extensively on this topic. I see the difference in understanding of this thermal aspects, especially thermal remote sensing is crucial in understanding of thermal remote sensing is crucial in mapping this, right? So I'm going to broadly talk about this. My content for the day is going to be like this. I'm going to talk about, the definition and history because a lot of time people wonder from where and when the urban heat island has started. Like I'm going to throw some light on that. And thereafter, we will look into impacts. So I want to start from impact because it's slightly outfit people generally starts from all the things and then finally they take you to the peril. So I wanted to start from the impacts and then I will talk about has been studied throughout and then different methods being used for measuring and then how one can use remote sensing and what are the do's and don'ts. That's more important, right? So, and then a couple of case studies from my work, my students, PhD scholars' work. I'll share a few insights from there. Over there, the idea is not to showcase our strength of working or something like that. The idea is to showcase certain cases where we felt there's something different happen in India, right? There are certain things which are common across the globe, but certain things are slightly different in India. So we want to, see those things. And then finally, we'll look into certain strategies or immediate action needed in terms of policy, because when it comes to mitigation strategy, we broadly know two aspects that one can work for. So what else one can think of a solution? If you're in different part of a world, can you look for something else other than the known mitigation strategy? So that's what we're going to discuss, and I'm sure I will leave ample time for discussion. My target is to finish it in 20 minutes. I'll give you 10 minutes for discussion. So we'll have plenty of questions and interactions if you like, right? So what are urban heat islands, right? Urban heat islands refers to the phenomena where it's all known, right? The urban area tend to have an elevated temperature compared to the surrounding rural areas. This is an example imagery. You can find it quite often in any of the textbook, publication or anywhere, that the city area tend to have an elevated temperature compared to its rural areas. The definition from IPCC is this. The same thing, right? It also says relatively warm compared with the surrounding rural areas. But what we have found, the understanding on this also changed over a period of time. Initially, the entire urban area is looked at as one heat island, and then the rural areas are expected to be warmer, right? But what we are seeing these days, especially at the advent of satellite imageries, when we are blessed with satellite imageries, right? What we could able to see is the urban areas itself has so many heat islands. There are more than one. You can see the entire urban area as one island, but then if you really want to make a proper understanding of heat impact, then one has to look the urban areas into pieces. Then if you look at that, there are more than one pockets, right? So that's what the understanding changes. But then the entire nature of this work, we should credit to this gentleman who studied this for London, and he published, the Climate of London is the first article which is published on this, is ideally looking at the temperature difference between London and its rural areas. So his observation was, the urban areas in London was tentatively higher, especially at night. Remember, it is an important factor. This is critical for anybody who is interested to look at research on urban heat island. What is an ideal time for studying urban heat island? Is it daytime or nighttime? I would say the best time, if you really want to see the urban rural temperature divide, then look at nighttime, right? Because where you don't have an external factor, you can obviously look at the radiated temperature rather than the incoming temperature from the sun. I'm going to look at the impacts in four ways, right? But then I'm going to zoom in into three, and then two, and then the other three I'm going to club. The first one is a health. As I told, I will start from impact, because when we understand, one of the major challenges in this area is understanding the actual impact of this, the problem. When you understand the impact of this problem, probably people will look into it across different parts of the world. Maybe today, some part of the world is not facing this challenge. For the city I belongs to right now, Bengaluru in India, was, 20 years ago or 10 years ago, if you ask people, they would have not bothered about temperature rise, right? But what we are seeing in last few years is rise in temperature. We still feel summer. Summer in Bangalore, nobody thinks of, but then today we are facing it, right? So, the idea is looking into these aspects and see if your city is getting into it or likely to get into it, then you can actually, do research and then alert your policymakers to, look this as a problem. Because once they look it as a problem, the solution comes. Otherwise, this is always ignored across the globe, right? And before we get into impact, we should also know the urban heat island impact is turned out to be positive in some parts of the world, turned out to be negative in the part of the world which I live, right? In case if it is in a cold countries where the heat which is trapped, try to minimize the electricity bill which is used for heating. Whereas in this part of the world, it actually adds to your electricity bill, right? This is just to set up a context because people have joined from different part of the world. For not everyone, it's a peril. It's somewhere it's an advantage. For some other people, it's a peril, right? So now, what are the health impacts, right? Elevated day and night temperature can lead to general discomfort and fatigue. Over there, it's clearly fine, right? We don't have to worry about discomfort and fatigue. But then, if you look for respiratory challenges, right? And especially heat cramps and heat strokes and heart related morbidities, if you have this, then the situation would be critical. Especially in case of India, if you look at the heat related deaths and heat related impacts, the mechanism to record this is very limited, but I'm sure it is the same case for the rest of the world also, because until identifying a person who is actually impacted by heat is a difficult term, because people try to largely categorize it as bacterial and viral infection in summer. But then um, some people are exclusively identified as a victim of this heat once they die. When in postmortem, people identify, okay, this is a person who has actually died due to heat stroke or heat stress, right? So it's quite difficult. The public health infrastructure is not equipped across many part of the world to look into this. And also the vulnerable population for this are children and elderly, and people in a context of the in India and other similar countries, the vulnerable populations are people who are going out for work, people, the street vendors, right? The people who sell things at street, the people who have small shops at street. They are the vulnerable community at in the summer. And also, this can, once a health infrastructure is weak, when you do a spatial analysis and identifies a particular area as a poor health infrastructure, then again the place is probably an vulnerable community, vulnerable location. Moving to environment. So a part of it is in fact covered by my co-panelist today, because once these things are interconnected, I see this as an interconnected stuff. I don't see heat as a separate stuff and pollution as a separate stuff, because all this will put more and more stress to people together when you have dense built environment also. Right? Certain things in the past, nature can able to help you and mitigate and ease the pressure from people. But then here, when you have more and more dense built environment, you have all these things together, and loss of biodiversity and with water quality degradation. These are the things which are common for any city in the globe, right? You will be losing biodiversity, we are losing water quality. When these things happens, the pressure always builds up, and then urban heat island also impacts the soil degradation. It creates soil degradation because it impacts soil moisture, affecting urban vegetation and ecosystem health, right? Now, here is the thing, I've clubbed energy, economy, and livability together. Because I believe, okay, let me not put 3 slides for it. Let me cover it in a single slide. Because if you look at the energy, increasing cooling demand in case of a subcontinent and other areas where the temperature is high in summer, you require the energy to cool your environment, right? In this case, a 2% increase in energy will be there if a temperature outside increase by 1 degree Fahrenheit. So that means a lot. You are actually consuming more and more energy. Eventually, you are putting stress on your grid, the electricity grid of a particular town. That's why it's quite common in many parts of the world to see some electric outrages at summer, because the consumption is quite high and high. As an individual, one can afford for an air conditioner easily, but then it is the overall city that needs to provide that electricity power to the people who may be able to pay more, who may able to utilize electricity to cool their room as per the need. But then there need to be an input on this, and eventually it comes back as a cost to people itself at the end. And the livability and tourism, real estate, these are the facts where when all the things goes bad, like when you don't have good ambient temperature, when electricity bill is going cause, when other factors are coming up, efficiency goes down. That's another thing. In When you have more heat, then efficiency goes bad, and damage to infrastructure again, be it equipments, be it other physical infrastructures, they get damaged because of the heat. All these things are challenges that this thing urban heat island can bring in. But what are the causative factors? The main causative factors are largely known, right? The largely known factors are like, non-porous materials such as asphalt and concrete being used, and more and more urban surfaces are coming up where it tends to trap the heat. I'm decoding. I'm not just going line by line on the slide. I'm trying to recode it. What it actually brings is like you're losing the capacity to dissipate heat at a fast, and you're basically holding heat. That is why urban heat island is pretty severe at night, because it holds the heat in the evening and then it start emits as a long wave in the evening, and then it affects the people, especially elderly and infants. So different methods for measuring urban heat islands. Okay. So, today we have remote sensing. We all know that we have seen the previous one as well. But what was the technique people used in the past? People used traversing. Traversing is a technique where you do physical observation of air temperature or surface temperature and move around in a particular vehicle or move through any other means on the ground and measure it at different places. And then field measurements keep the constantly observing air temperature observations or the moving part where you can measure at different points of the city. But with the advent of remote sensing, we are fortunate to look at through aerial based platforms that includes helicopter, aeroplane, and also these days UAV. In addition, you have space based assets. That's all our Landsat and other satellite data sets which can provide. Now, there's other component called IoT based sensors where you can fix it on particular facade of a building and you can measure heat constantly. Now, where these things are useful, like one would think like, oh, all the three are outdated. Perhaps satellite-based technology would be the best thing, right? But that's not the case. So everything would be useful, because if you're looking at from space, you have certain limitations and you have certain opportunities. You can look at the entire city, right? But what you're measuring in space-based temperature is the land surface temperature, which is the temperature of the skin. You're not measuring the actual air temperature, which impacts you, troubles you. But there is a relation between air temperature and surface temperature. People try to decode it from remote sensing things. In fact, we did try to decode it when we did. This was a time, it's been a long time. 10 years back, I completed my PhD. But then this is the time when we try to do some research by integrating. In fact, it could be the world's largest urban heat island fieldwork we have conducted. We had space-based platforms which are capturing, passing through Hong Kong, and we had ground-based systems where we had traversing. We've even been on field measuring surface temperature, and we had helicopter-based thermography, and we had, observatories which are fixed, and then we had smart sensors which are fixed on building facades and so on. Why we were trying to do this is to cover 360-degree of urban heat island, not just an inference from space. An inference from space, a temperature map like this, can only give you a surface temperature, right? It could be a rooftop temperature. But is it a reality? I would say no. This is very much important for people to understand what it gives, what it not gives. Because another thing I want to bring out, because we are running out of time, I want to bring out few things here. When you use remote sensing, I'm going to tell you what are the things one needs to take care of, right? The first thing to take care of is identify your right spatial resolution for doing it and right sensor for doing it. If you're looking for a district level analysis or even coarser than that, covering larger areas, just slightly bigger than city, then go for a MODIS kind of thing. But then don't use MODIS data to look at a city level analysis. In my understanding, that is not good enough to characterize urban variations, right? But then Landsat been a good source for a very long time to look at city scale analysis, and thereafter Sentinel BNet for a while, and then many sensors are coming up. Indeed, we are getting our first commercial payload. Satellite Wu is bringing up a couple of payloads where you can use and measure temperature at precisely at rooftop level, right? These are things, but then decide what is your objective. Are you going to measure drought? Are you going to measure land surface temperature for urban heat island application? Are you going to use the land surface temperature for any other application? The same land surface temperature can be used for different things, right? So you need to be careful on it. Second thing is understanding on the assumptions being used in calculations. As I told you, what is being measured by satellites are land surface temperature. That requires emissivity. That requires, other aspects. So you require understanding of atmosphere. You require understanding of surface. And if you use algorithm, it's quite easy to model in a platform like Google Earth Engine or any other computing platform. Well, but you need to look at what are the assumptions being used. It all goes with assumption. How different a thermal camera, which is handled, and how different is a satellite imagery. If you look at it, there are certain assumptions being carried out in thermal cameras, whereas satellite remote sensing works in a different way. What you generally calculate is an energy, then you translate into temperature, that too in top of atmospheric temperature, then the land surface temperature. So there are certain things which varies, and there are certain algorithm variations. So that is quite important for anybody to look at what you actually wanted, how it is varying. And second thing, do not look at a particular day temperature as a representation of an entire year. Because if you look at, first say, if you look at a particular day in summer and then say, oh, the temperature of Delhi and Nairobi or any other country or any other city or any other part of the world is this for the particular summer, it won't be, because that is an instantaneous and that is derived based on the things happening on the last few days, right? So there need to be a mechanism. Either take an average of it, take a look, observe the long-term patterns over there for a couple of months, and then take a decision on this is what the temperature of a particular city is. It's going in an upper trend, it's going in a lower trend. We did this kind of mistakes in the past. That's why I'm just trying to tell these are the things that people, need to avoid. And another one is understanding the interaction between the biophysical features that we discussed, how NDVI interacts, how NDBI interacts, how Barron index interacts. But then a lot of time people miss out the natural phenomena on the ground, and they presume as a result of some anthropogenic activity. For say, if there is a facade of a building which is radiating due to the natural material which is being used, one can always consider that as an anthropogenic emission happening in that building. If the building has an electrical component which is emitting, that comes as an artificial heat, right? That's an addition to the incoming radiation. But these kind of things one need to be careful when interpreting at final level. When you're going broader, if your objective is to relatively compare temperature between A and B, it's fine. But if you're going for quantitative, more quant, then you need to look into this. I'll quickly run through this part of the slide because this is important for anybody to understand, and ignore this part. I just put it for a fun to say, like, look at this graph. It's more like a heartbeat, right? But then look at the air temperature and surface temperature. There is a particular point when your air temperature and surface temperature comes closer, and that is for a subject like water body, right? When you have water body, the understanding and interpretation of the land surface temperature has to be different, whereas the built environment, it is different, whereas open ground, it's different, where vegetation, you need to look at different, because each of them has different intrinsic properties, right? So now few glimpse of this from our work. Like, I'm not going to take you detail. Of course, you can refer our publications and feel free to look into it. But then I'm going to talk about a city like this. Look at a city, the capital of India. The kind of change it happened, the kind of urbanization happened. It's massive in a few years. It's basically the city expanded all around. There are a couple of satellite cities like Gurugram, Faridabad, Noida, Ghaziabad. All these are satellite towns which have come up, and then expansion happens all across. So what we did is to figure out which part of the Delhi NCR, the National Capital Region, is having higher impact. Then we figured out to somewhere called Gurugram. It's one of our satellite city where the temperature also went up for a longer period, and also we looked at the growth factor also gone up, right? The building environment also went up. That eventually translated, but few interesting results on that I want to share. I'm not sharing image here, but then the important aspect is um, we were all in a belief like every part of the world, the high rises are emitting more and more heat, right? Whereas we observed it, the built environment, which is closely packed and which is old in some parts of Gurugram, especially the old towns, right? Those are the one who are more heat emitting region compared to the built environment, because the built environment are spaced. The built environment in Gurugram is different from a built environment in Hong Kong, where it's densely packed. So that is a difference when, making interpretations and things are required. And also another interesting fact, I'll run through this, but I'll explain it because I'm left with 3 to 4 minutes. The city was cooler at certain time, and the external region, the surrounding rural areas were warmer. That was quite a surprise thing, right? Like the rural area is warmer and the city is cooler. Just because, the kind of soil, especially this happens in summer, the kind of soil which is exposed to heat, and when harvesting is completed, the soil traps more heat during day and it emits more than a built up environment. So those things are pretty, different in India compared to other parts. And then there's not a case for entire India. Indeed, it's happened in northern part of India, but in southern part of India, it's not happening there. Since I have 2 minutes precisely, I wanted to go to the way forward section because this is quite important. What is the solution for these things? Like mitigating urban heat island, well, we can look off certain mitigation factors. One is increase the green cover, right? Everybody says quite easily increase the green cover. Second is increase the water body surface cover. What else? Can we able to increase green cover everywhere? And the question comes in, which kind of species is good for mitigating it effectively? Not every species is good at mitigating heat. So identifying right species, my research scholar Pallavi is doing on that, identifying a good species which is suitable for a particular local sites are something where people are interested in, right? And then again, water body, when water is scarce in a city, how can you increase the water? And how can you spread water everywhere, right? You can't do that. Then there need to be another solution. What are the other ways? Like energy efficiency aspects, well, good, taken care. People can look at with the help of technology, it can be done. But what else? Use different glasses and use different, factors which can bring down energy. Here is the innovation component. When then, if you're an entrepreneur, if you're here and if you want to look for a business idea, look for solutions for this. Try to find a solution for this. I'm happy to discuss with people, anybody interested on it offline after this, because we have very short time here. And there are many ways you can look into it, be it smart device, be it smart solution, it is required. And I always believe if you, bring out the challenges, bring out the kind of scenario that you're seeing on your city to your local authorities, urban planners and other stakeholders, who may able to bring out policy intervention and then sort of, because in India it happened in a couple of cities, especially Gurugram, the good policy maker brings out an innovation, kind of a heat map, a heat action plan for the city, and another couple of cities in India do have. The idea is to bring out the factor. Understanding this as a peril, then the mitigation factors comes in. But the mitigation factor is not again one for everywhere. It's like you can think of different solutions based on the sustainable things which are available in your cities, but not necessarily increasing vegetation cover and then increasing water body. The last thing I would say is there is an opportunity for cross boundary solutions and opportunities, right? Interactions need to be there beyond boundaries, because when it comes to urban heat island, for say India and Pakistan do face similar challenge on managing cities, right? Anybody can learn from anyone on this aspect. Per se, the other part related to, let's say, Bangladesh or anybody else in the region has a similar challenge, right? So what about learning experiences, learning transboundary cooperation for even for mitigating these urban challenges would be the need of the hour. I think that from here I stop, and I love to thank the ISPRS working group, especially Dr. Laurent, the president of ISPRS Technical Commission 3, Dr. Murali, Krishna, professor and working group chairman, and fellow speakers, and of course Lakshmi. And especially we need to thank speakers who are from different time zones. And we're happy to take questions, Lakshmi and chair. And yeah,
Thank you, Professor Nityanandam. I'm excited when you showed or telling about the smart sensors deployed in Hong Kong Technical University campus. It is really awesome that such things. And one of the other the important aspect you mentioned is in your way forward aspect for entrepreneurship, startups. And this is what exactly I am looking for how do we build up entrepreneurship and startup with in the space sector with focus on remote sensing applications or geospatial technology applications for earth environment and sustainable development. I think this is a very important offer you have made, and some of the things basically, can we think about automation of urban heat island mapping, and can we automate the pre-processing of the data at least? So some of those issues which have come out after listening to you, I think very interesting talk. So Dr. Lakshmi, any questions other than, I also put one question there for information.
Yeah, maybe I can start with that, and then I have also
go to other
asked,
question.
if anyone is interested to ask the question, you can even raise your hand if you want to ask it directly. We can unmute. So maybe to start with Dr. Murali Krishna's question. So
But a comment actually.
it's actually more as a comment. Yeah, so it's like, why not it be possible to leverage cloud computing platforms like Google Earth Engine or Amazon Web Services to automate urban heat island mapping? Yeah, that's what, and he's suggesting why not considering it as an important topic for research for some potential scholars attending this webinar. And just to facilitate this one, I thought like what we can do is, I just wanted to let all the participants know that we have a Discord channel. This is not like official Discord channel. We wanted to make it official, and our idea from ISPRS SC was that, like, there are a Stack Overflow or some dedicated Slack channel or something. We thought maybe through Discord, we can create different small channels like remote sensing, photogrammetry, or different theme-based small channels where can expert come and give their thoughts. But then we got to know that some parts of the world are not allowing to use Discord, but the channel still exists. We still have like some students joining, and now especially that we have student chapters, they have joined it. I can share the link. So if anyone is interested to join, we have channels, you can join and start discussions among yourself. Because we haven't officiated, we don't have any kind of expert on ourselves, but all of you can discuss, interact, or collaborate with each other. So I'm just putting this as a link, and I would like to hand it over to Dr. Nityanandam for his remarks.
Thanks, Lakshmi. I like the way you are managing things, with effectiveness. So if I have to answer precisely, yes, there's cloud computing platforms are really good. If a city is already studied extensively on heat island intensity, for say, that is something where you can start and measuring land surface temperature. But the importance of mapping it precisely and accurately is to look at the causative factor. If the values are correct, then it helps us to figure out what is actually contributing and where it is being contributed, and what it happens spatially and temporally. So for that, cloud computing would be really helpful. And downstream applications, now we are moving something like edge computing as well. So you don't have to do it on the ground. You can do it from space, and then you can figure out things much faster, right? That is something can be done. And I think there's a similar question on utilizing mapping, managing space, the both spatial and temporal aspects, right? There are a lot of fusion techniques being used. The kind of work on this area is exists for more than a decade. So you can look at the fusion techniques where you can fuse the data to better produce it. But then, I do believe on the physics of it. I look at from the physics aspect of it. Ideally, I'm a physicist, so I look at it by looking at once the data is lost. I believe on fusion techniques to some extent, but then once an information is lost, you can actually you will not get 100% right information, but you can get an information where it was lost due to some other certain aspects, right? So that is possible in digital image processing. You can try that as well.
Okay.
Thank you so much. So there is another question. Do you want me to read it?
Yeah. Where is it?
I can read for you.
Yeah.
So the question says, have you compared, it's Thai Pham, if I'm pronouncing correctly. Thanks for great presentation. I'm from Vietnam. My question is, have you compared with air temperature, and how many degrees have air temperature and elasticity increased in your area?
See, this is a very, the answer for this question is not same, and it is not going to be same even if you say area. If I measure an air temperature in this room which I'm sitting, which is air conditioned, and the surface temperature, that again, if I get out of this room where the materials are same, but then there is no air conditioner, then the variation exists. It's not going to be same. When both the air medium and surface medium are in same material, then you get same temperature. Even within the same room, I'm sitting in front of a metal, then the metal temperature is different, then the surface temperature of a wood is different, surface temperature of a floor is different. Everything varies. So that's what it's not going to be an easy answer where surface temperature and air temperature is how much it is different in your area. Perhaps I can answer it in by this way. If I look at based on our research in Hong Kong, like how we identified surface temperature and air temperature, especially on different homogeneous surfaces. We went out to park, we went out to the rooftop, we went out to water bodies to understand how much it is varying. That is what the precise research in translating the surface temperature that you measure from remote sensing, somewhere taking it to the equivalent of real air temperature on the ground by doing regression, and then transform the surface temperature data into an air temperature data, which is more realistic and important for anybody who wants to mitigate urban heat island. That's a thing, but then that comes from a lot of ground-based measurement. That comes your traversing, there comes your thing. But the challenge is when a satellite passes, you can't do measurement aram say in aram say means you can't do peacefully in different places in your own time. You need to do a simultaneous measurement, probably an hour before and after the satellite overpass is reasonably good. And the moment you go far from that observation overpass time, then the results goes bad.
Thank you so much. Saifam has a follow-up question. Sorry, do you want to say anything, Dr. Murali?
No, I think we can just.
Yeah. So the follow-up question says, how is different? How is, or I'm not sure if it is, what is different between LST from satellite and IoT?
See, this is something like, COVID has actually taught us a good thing, right? It has taken thermal remote sensing to the next level. People have started using thermal infrared guns for measuring temperature. But how many of you observe the temperature difference between when you keep the thermometer physically attached to you and when a temperature is being measured from a distance of few centimeters away from you? Because when you actually measure it with your surface, keeping it in an armpit or keeping it inside your mouth, you're actually touching the surface and measuring it precisely. Whereas if you are using thermal remote sensing, you are getting it right, it is precise, but then there are certain assumptions carried out inside it, right? That's in terms of emissivity, in terms of calculations, that can give you a near equal temperature, but it is always lower. It's not going to be higher, it's lower. That's why even doctor says that the thermometer difference is 1 degree. You need to add up when you do it by thermal infrared. Thanks to COVID for taking this technology. At least the only good thing happened in COVID is this, in my understanding.
Yeah, thank you. May I request Dr. Lakshmi to give any idea, any inputs regarding your student consortium here, for any specific, take 2 minutes and anything you want to highlight regarding your student consortium here.
Before mentioning about that, we have a last question. Actually, it was already asked before in Q&A, and it's a bit long, so I thought like maybe we can take it as last question. So can we take it as last question?
Why don't you send us a mail and answer the question? I think it's. I mean, let it be brief answer. That's all.
Yeah. So the question is by Christopher Mathison. It says, "Thank you very much for an interesting presentation, Dr. Nityanandam. Do you have any recommendations on how to capture both high spatial and temporal resolution with satellite data? Second question is, do you have any recommendations on heat stress index that can be derived from satellite data with demand on both high spatial and temporal resolution? This is in order to studying health impact among inhabitants distributed over a mid-size to large city over both shorter and longer time period. Shorter, he means capturing effects of heat waves, and longer is referring to chronological chronicle exposure time periods. Thank you.
Yeah, there's certain index, I'll make it short. There's certain indices that we have calculated in our research to understand the long-term impact of a particular area. The answer for managing both space and also the temporal aspect is like if you ask the appropriate way is going for more of constellation, and then it's a resolution like what satellite who is trying to provide to us, right? But then if you are trying to use different forms of data, then managing it and removing errors and bringing it, standardizing it to same platform, and then comparing is another possibility that one can do along with fusion. Right? These are the two things. And then stress can be looked at by calculating certain indices. There are certain technologies, but you can derive something based on your area, your micrometeorology, your microclimate of your study area, and so on. Right? You can always feel free to reach us, and we'll be happy to work with you on this if you need it. Yeah, AI is going to be the next step. It's not going to be easier way for using in UHI. Yes, you can calculate easier. You can calculate LHI easier in an easier way, but not the interpretation of it.
I'm in a meeting.
Thank you.
Yeah, thank you so much. So yeah, over to you, Dr. Murali Krishna.
But I want you to tell something about your student consortium. You are in the torch bearer of the entire program. Anything you want to communicate to these people about the? Let me tell to everyone that wonderful work being done by Lakshmi Thapa and her commission on the student affairs and other things. I think I must first thank you for all your support, Lakshmi Thapa, for wonderful support. So you take
thank you so much.
And 1
minute.
Thank you.
Yeah, I appreciate it. I'll make it very short because we are going to have these webinars every month as well. There are other working groups webinars that we're going to launch where we can interact. So just to tell you, considering higher number of attendees we have here, if you want to be the member of student chapters, if you are students or young researchers below the age of 35, you can simply fill up an application form available in our website. It hardly takes like 2 minutes. And you can be our member for free. And then also if you are above 35, I can see lots of people are from university, like professors or faculty from university. So if you want to get associated with ISPRS, you can also be an individual member of ISPRS for free. Again, the application form is very simple. You just need to go to ISPRS website and fill it up. Both you will be receiving emails regarding lots of opportunities from both the sites, and there are lots of scientific and research initiatives, travel grants for attending conferences, information about journals that ISPRS is publishing, and I think those will be wonderful resources both for the faculties, students, and young researchers. That's all from my side. Thank you.
Thank you, Lakshmi. Before I request our president to tell the concluding remarks, let me thank both the speakers for their wonderful presentation and involvement in the topic. It is a hot topic. It has generated a lot of heat, from both the sides. Thanks for everything. And I want to appeal to all the participants here. See, we are all personally and also professional. Some of us are thinking of working or started working in terms of promotion of entrepreneurship and incubation startups in the area of remote sensing applications, which not taken place all over the world in a significant manner. I see there is a big gap, because when I say geospatial technology, people only entrepreneurship in satellite launching, software development, etc. There is minimum development of applications, how they would use the technology and integration with the geospatial AI, generative AI. There's a lot of scope for development of incubation, innovation, and entrepreneurship. I'm open for it. I gave my email in that one. Please, anyone is interested, please send it to mail. I'll be happy to interact with you, and let us create a small cluster of the people from different parts of the world on development of this particular application in terms of incubation, innovation, and also entrepreneurship. Thank you. May I request Dr. Laurent for his concluding remarks. Thank you very much.
Just say thank you. Just say thank you to the two speakers. Very, very interesting and relevant research that was presented today. Thank you to the Student Consortium, Lakshmi, your very, very valuable support as always, and to you, Dr. Murali Krishna. Your working group is very active, and I would say to everybody, please check the ISPRS web page from time to time, just to see that to wait for the announcement of future webinars, which are really very interesting, a very good way to meet people, to spend no money and learn very interesting things. So thanks a lot, and I think it's time to conclude and to go back to our activities. Thank you.
Thank you very much.
everyone.
Thank
You
you.
all.
Yeah, bye.
Bye.
Thank you. Bye.
Thank you, Patricia.
Mhm.